Okay, so in this project I have implemented some generic solutions for forward and inverse kinematics of a robotic arm. The links in a robotic arm are implemented basically as a function that you can call to create a Denevit-Hartenberg matrix for a specific joint angle. And when you take a sequence of these links together, you get what we call a kinematic chain, which you can then forward a joint configuration to essentially get a series of matrix transformations that, when applied sequentially, will basically do forward kinematics for you, which is easy enough. But for inverse kinematics, things get a little bit trickier, and for this project I'm using an algorithm that is going to optimize a heuristic function to do inverse kinematics. Basically, we have an algorithm that's iteratively modifying our joint angle configuration to minimize the Euclidean distance from a target position to the endpoint of our robotic arm that we obtain using forward kinematics. The algorithm we're using for this is the Broyden-Fletcher-Goldfarb-Shano algorithm. It's a modification of that. It's one of these gradient descent type algorithms, but the modification of it enables some boundaries on our joint angles. So that's very desirable. Now let's take a look. This is the robotic arm configuration that we're going to be using, and you basically just would modify this if you want to try a different arm. So let's run this. So here's our robotic arm in the default configuration. And here we are randomly generating a target position, which is the red point. And then this is the joint angle configuration that we've obtained using inverse kinematics to reach that point. So you can see it works pretty good. There are some problems with it though. Sometimes it doesn't work on some points. Not entirely sure why, but I think it probably has something to do with getting stuck in a local minimum instead of a global one. But I'd have to do some more investigation to find that out why. So you can see it works pretty good. Okay, now I think the only thing left to do here is to take the number of links that we have here and just cranking that up. It's pretty long. That's crazy. It's about what I expected. You can see, we've got some collisions because we've got too many and we aren't doing anything to make sure that we're not intersecting these lines, which is not optimal for a real robot, but nice loops. It's about what you would expect. Looks kind of like a tentacle of a sea monster. So my computer is starting to get mad at me. So that means it's time to take the number again and double it. Okay. Now let's give that one a shot. Pretty long. So, taking a bit longer than before. Excellent. This is fantastic. All right, thank you for watching. Goodbye.